Number 9. Guinness claims the amount of beer in draft cans are normally distributed with a mean of 12 ounces and standard deviation of 10. And then, so somebody tests 8 beers and found standard deviation to be 0.15 ounces, which seems larger. So the question is to test the claim if this is significantly larger. So standard deviation is greater than what Guinness reports. All right, so let's go through. This, by the way, is testing for the standard deviation, sigma. And if you were to use, well, this is about the only one in section 7.6. This is the only one that doesn't have a quick calculator command, and it uses a chi-square distribution. So we're going to have to use a traditional method in this case. So let's go through the 8 steps again. The first step is to state the claim. And the claim is standard deviation in words is greater than what Guinness claims, which is Guinness claims it's greater than 0.10, 10 ounces, or 0.10 ounces. So in symbol, it would look like this: our standard deviation greater than 0.10. Step 2, the opposite. Standard deviation is less than or equal to, and this equal to is important. And some books can just they just put sigma is equal to this, but I want to call your attention to the fact that this step 2, the logical opposite, has a condition of equality. That's important when you go to step 3, because here you identify which one your null hypothesis is and which one is your alternative hypothesis. Well, it turns out that our null hypothesis is always going to be the statement with the condition of equality. So it's this one. And our alternative hypothesis is the original claim. And we want to make a note of that here, just to remind ourselves that that's the claim. So step 4, significance level. They give us a significance level, 0.05. Your alpha is 0.05. Again, if there is no significance level given in the problem, then you just assume it's 0.05. Step 5, your statistics that we're going to be using is I'll call it TS for test statistic, and then let's use the appropriate symbol. It's going to be a chi-squared test, and the chi-squared test is is S. Hey. It's a good thing you guys have your notes with you, huh? Yeah, n minus 1. So the chi-square test is n minus 1 times the sample standard deviation, or the variance since it's being squared, divided by the claimed variance. Oops, let's call it sigma squared. Okay, so we compute this in step 6. Not only do we compute this, our test statistic, but we also need to find our critical values. So actually we can do that up here, I suppose. Our n is 8, and our sample standard deviation is 0.15, and we're testing sigma. Now I know that we're testing sigma is less than 0.10, But in the null hypothesis, there's a condition of equality that says sigma is equal to, and so that's what we'll use for sigma. Okay, so a couple of things that we're going to need in our calculators. We're going to need to compute the test statistic. So let's take out our calculators and compute the test statistic. It's a fraction, so it's 8 beers minus 1 is 7 times the sample standard deviation, which is 0.15. You square that, divided by 0.1 squared, that's the population standard deviation squared, or the variance. Get 15.75 is our test statistic. And then we need to draw our graph and mark our critical values. So if you draw the graph first, I think it'll be helpful to identify our critical values. This is a chi-square distribution, so it's not like a bell curve. What else should we know? We should note that by looking at the alternative hypothesis, we have a greater than symbol, and it points to the right, so this will be a one-tail test on the right. So this is a right tail test. Since it's one tail, we're taking all of our significance level, and so that total area to the right is 0.05. And this information is important for us to figure out how to find our value. So area to the right is 0.05, and our degrees of freedom is 7, so that's 14.067. 14.067. So we got 14.067 is our critical value. And our test statistic is greater than that. So that helps us come up with our conclusion in step 7. Since the test statistic is 15.75 is in the critical region, we reject the null hypothesis. Now, step 8 is our conclusion, our final conclusion in non-technical terms. So let's get that written down. And we go through that flow chart again, and since the condition of equality, since the claim does not contain a condition of equality, we go down to the arrow and then to the second set of problems, and since we rejected the null hypothesis, we actually support the claim. So the sample provides evidence to support the claim that the standard deviation is greater than what Guinness reports. That's 0. Okay, the second part of this problem is really just asking you to think about what you found in your result. Is there alarm? Should you write about it? And technically, according to the result, it's Guinness is not being consistent with what they're saying. So you can say that yes, this person should write about. Um, since Guinness is not being accurate. With their reports. Okay, I think this is it for this problem number 9.